So in the last lecture, we saw what the photoelectric effect was. In this segment, I'm going to explain what the experimental setup for the photoelectric is. So for the photoelectric effect, we have a vacuum bulb made out of glass. And in this vacuum, we have a metal plate and a collector. And what we do is that we hook up these two things between a potential difference, and then we apply ultraviolet light on this metal plate, and as a result we get electrons emitted from this metal plate, and if these electrons reach the collector, then we get a current in our circuit. So how do we use this contraption to measure the maximum kinetic energy of the electron? So what we do is that we apply the potential. So along the x-axis is the potential, and on the y-axis is the current. And here it's the zero of the potential. So in this direction we get positive potential, and here we get negative potential. Now, if we apply a negative potential, then what's happening is that the collector is repulsing the electrons. So if we have enough negative potential so that even the electron with the maximum kinetic energy cannot reach the collector, then there will not be any current. But if the negative potential is even a tiny bit less, so that the electron with the maximum kinetic energy can reach the collector, it'll contribute to the current. So the retarding potential, we get a current for the negative potential like this, and then the current becomes constant. And this is the stopping potential. And if you just multiply this with the charge of the electron, we get the maximum kinetic energy of the emitted electrons. This is a very clever experiment.